Thank you very much, everyone, for attending today. It's wonderful to see some familiar and some less familiar faces. I've already had a few conversations upstairs, some very interesting stories. There's a lot of experience in this room. Interesting, we're seeing some people not in the surveying side of things who are interested in learning more about today. So that's the agenda. We are here to share what we know in a basic format so you can better understand the pain points of traditional methods and the benefits of a drone type platform for GIS and surveying methods. I appreciate there are some people who have a lot of experience in the consumer side of the industry and want to learn more. So today what we'll do is we'll go through the basics. Towards the end we'll have a questions and answers section. You'll notice on your chairs you have a small yellow piece of paper. We would much appreciate if you could fill the questions in on that paper today. And before you leave, we'll also be handing you a certificate of attendance. So don't leave unless you get that. That would be very helpful if you could do so. Once the session's concluded today, you're free to go upstairs and enjoy more refreshments, networking session. And again, thank you very much for attending today. Okay, so to start off with, I'm going to talk about a few of the pain points when we're looking at traditional methods of surveying. And those pain points are in both the accuracy and precision of using a traditional method, comparing that to a drone-based platform. Scalability and flexibility is also a very difficult thing when you're using traditional methods. So to touch on that, we're going to start with accuracy and precision. Imagine a scenario, there's 100 square kilometers. You're giving work to conduct a 3D or a 2D model of that area. You're using ground-based platforms or tools. You're introducing human error. You may be in a mountainous area. You may be in a desert area. You may be in an inaccessible area. How do you conduct that survey efficiently without creating human error? You might not be able to access the entire scope of that area. And because of this, you might see increased labor costs. It takes longer to access that area. The data takes longer to process. You're charging your client more for poorer quality data. So that's a second bugbear with traditional methods. The time it takes may also be a big problem for your client. They give you a certain time frame to conduct that mission, but because of the landscape, you're unable to qualify or manage that workload in the time constraints given to you. And that is a big problem we see with traditional survey methods in this region in particular. Hazardous, harsh environment, preventing quantitative and qualitative data. When you're looking at using traditional methods, there's a scalability issue. You're giving 10 square kilometers, the client then is happy with your work and wants to expand it to 1,000 square kilometers. You may not have the manpower to conduct that in the time frame given. How do you scale that? How do you prepare for that? How do you conduct significant manpower to scale to that level? And how do you adapt to a harsher environment compared to your first project? These are all variables that are outside of your control when using traditional ground-based methods. And this is why we're here to talk today about the benefits of using a drone-based platform. So at this stage, I'm going to hand over to my colleague, Sam, who's our GIS specialist. And he's going to talk about the drone solutions that are out there that will benefit you. Thanks, Sam.
Thank you, Scott, for all your valuable insight on how the traditional serving work. So tools are really important in serving or any workflow. So DJ offers really special tools for drone-related service. So in the first, we are going to speak about the Mavic 3 Enterprise drone, so which is compact and portable. Like I can carry in my pocket if I want to. And this is very powerful to be used on serving grid. So you can see the drone has a wide angle and a telecamera. So we are using the wide angle camera for surveying and mapping because it got the 4x3 CMOS sensor and 1-inch and the mechanical shutter. So the benefit of using a mechanical shutter is that you can get the data distortion free, which means your data is accurate and you are confident enough to go on the field and get the data and make any surveying work as more precise as possible. Also, it offers the telecamera, as I told, so it offers a 52 times zoom capability, which can be used on inspections too. So you can use the small drones to make both surveying and inspection possible. And with the RTK model on top of that, you are expecting a centimeter level accuracy data in your daily life. And the drone offers 45 minutes of flight time in which you can cover an area of 2 kilometers square in a single flight with the small drone. So maybe I will just pass on to the team so anyone can see the drone, how the drone is and how compact the drone is. And speaking of the accuracy of the data, so using the RTK module on top of the drone, you are expecting accuracy of 1.5 centimeter in vertical and 1 centimeter in horizontal. So which means with the small drone, you can make a survey grade accuracy as possible. We will be showing how the drone works later in our workshop. So let me speak more about the next drone, which is an upgraded flagship from the Matrix 300, which was in the Matrix 350 drone. The Matrix 300 was in the market for about 3 years, and it's widely used in different application, whether it can be surveying and mapping, inspection, public safety, and most of all, very importantly, public safety, because people are using this as everyday drone in to detect and inspection with the thermal drone. So the Matrix 350 is an improvement over the Matrix 300 drone with key improvement of the night vision FPV camera, in which you can work in your nighttime without worry about hitting something, because the first person view camera is an added obstacle avoidance sensor. And the M350 drone is upgraded from 15 kilometers FCC range to 20 kilometers range in an FCC area. With the 4 antenna design, you are expecting it to be more accurate and get the timesync 3.0 data, in which the controller, the drone, and the payloads are synced together to get most accurate data. So just the drone is not enough to get the serving work. So we have a multiple payload option. That's the versatility of the Matrix series. So with the Matrix series, you have the options to change the payloads depends on your application. So the first one we are going to speak is DJI L1. DJI L1 is an in-house LiDAR-based drone payload from DJI itself, which is the best in the market currently available, comparing to your traditional laser scanners, which will be more accurate, definitely, and more pricey too. The L1 is the cheapest and the best drawn LiDAR payload available in the market. So with L1, you are having a 1-inch CMOS sensor, which will be an RGB camera, and the LiveVox frame sensor, which is a LiDAR-based sensor, and the IMU, which is inertial measurement unit. All these combined together, you are expecting a accurate survey grade result on the mapping field and even in a 3D construction. So using all this together, L1 is more capable of using in any survey grade operation in your everyday life. Also, the new features added was live cloud point view, which will be showcasing in our workshop. So briefly speaking about the live point of view, when you are doing a mapping or surveying in the field, you don't have to go back to your office and process the data in any other software. All the live cloud points can be viewed on the controller itself. And coming back to the next payload, which is P1. P1 is the full frame sensor from DJI. So this is the first full frame sensor from DJI, which is very accurately made in 45 megapixel sensor, and it got a mechanical shutter too. As I informed earlier, the mechanical shutter with the 45 megapixel, you can imagine how accurately your data is. You can cover 7 kilometers square in a single flight because it got 45 megapixel sensor compared to the CMOS sensor. The 45 megapixel sensor is triple the size when you are taking the data. If the CMOS sensor drone can take 2.5 kilometers, so this is 3 times more the area coverage with the accuracy of 3 centimeter horizontal and 5 centimeter vertical when you're flying in an 100 meters height with the GST of 3 centimeter, and we are considering the overlap of 80%. So let me speak about these things. So when you are flying the drone on 100 meters, the speed of the flight will be 13 meters per second, and the GST you are expecting the ground sampling distance, which is the accuracy meaning in surveying application. So with all those, you are expecting this accuracy. And it also offers 0.7 seconds time interval, in which every 0.7 second you are capturing the photos automatically, or you have options to capture the photos manually. So the P1 also offers smart oblique features, which will be shown and explained later in the stages. And coming back to the tools, so DJI DRTK is a tool which is a GPS base station. It's a normal GPS base station, but it's IP65 rated. That means it's more robust and reliable compared to the GPS station available. And it's the most compatible GPS base station for the DJI drones. So in which you have an ability to get centimeter level of accuracy. So the ecosystem of the DJI, let me speak about the Mavic 3 Enterprises and the DRTK. So you are using the Mavic 3 Enterprises with the DRTK. You are expecting a worry-free centimeter level accuracy. Same goes in the Matrix 350 with the P1 and L1. So you are using the DRTK base station with the drone. So you are expecting with the confidence of a centimeter level accuracy with which you can justify your client. So you are like enabling the drone operation in less point of time and more accurate result compared to the traditional service. So Mr. Ashraf Mr. Ashraf, who have 8 years of experience as a survey engineer, will run through how they have done the drone operation in a challenging condition.
Thank you, Sam. Thank you. Welcome, everyone. Okay, we have one project. We did the project like before 2-3 months in Fujairah and Ras Al Khaimah also. That project, the aim of this project to have the ortho map and digital terrain surface, and the area was like a small plot around the Fujairah between the mountain was 1.3 square kilometer. This aim of this project to deliver ortho map and digital terrain surface, two kind of this digital terrain surface, DSM and DDM, also point to cloud. Additional also we have vector data and GIS format to digitize the ortho map. We face in this project so many challenges because of the terrain. You know, in Fujairah, like the terrain is too hard. Also, to have a good signal of GPS, the drone. So to achieve this good accuracy, less than 10 centimeter, we use DJI Mavic 3 Enterprise with the DRTK2, and also we use the ground control point to achieve this accuracy. But in this case, in Fujairah, the challenges we have limited access to the area, and there's a bad weather there. It's near to the coast, so the wind is too strong. So to have this good accuracy, we need to achieve this accuracy. So our plan there, we need to have good plan, how to plan the mission and how to plan the GPS there, how to fly across the wind or not across the wind. So our plan there to have this accuracy, we defined the flight path and altitude and which sensor we use. Altitude was there like 120. Our GSD was like less than 3 centimeter because we need good resolution to determine all the future there, building, trees, all the rock, road, because we need to find where is the pipeline in this project. To achieve this accuracy, we use four, like we call four orders. Zero order, the course data from the government. This course data from government will give you good accuracy. After this course data, we establish our FITS benchmark. Around each area, we have 3 benchmark to achieve this accuracy. And we compare our benchmark later with government benchmark. We have it from municipality. So later, during our flight, we use ground control point. Our ground control point, you can see here like a marker, like a sheet. Also, we use a natural marker here, like a sheet. Yeah. So this is the workflow how to plan the mission with drone with GPS. So drone will connect to the satellite. Also the benchmark, also the ground control point will connect the same satellite. When we have when we plan the mission, we should the drone connect the satellite and also the benchmark. So to have good accuracy, we should connect both of them with this satellite or like so many satellites, not like one satellite. But in some area in Fujairah, we don't have a signal to like connect to the drone and benchmark together with the satellite. So we use PPK method, post-processing, like post-processing kinematic to process our data, our image, and our ground control point in the office after we have we collect the data. Okay, to ensure we have good accuracy there, because our aim this project to have less than 10 centimeter accuracy, we establish our benchmark, because later if we need after 1 year, 2 years to use it, this is our benchmark. And our ground control point, as you see here, this is a marker. Also we paint some like in the rock, maybe we can use it later to ensure this is good accuracy. We need to measure each marker and each paint in the ground. Like we measure it as rapid static or we measure it with RTK, depend of the like a situation, like if they have a good signal or we don't have there. This is our drone data capture workflow. This is how we plan the mission. We plan it like a parallel with a mountain, because we have here 2 mountains. If we make it like a perpendicular, maybe the drone will hit the mountain. So we plan it parallel. Also, we plan here 90% overlap and side lap, because we need to determine each feature, like if you can see the trees, building, road. We need everything here around the pipeline, because here we have pipeline. Our aim of project to determine the pipeline and all the future around this pipeline. So here, this is located of the ground control point. If you can see here, this is our pipeline in the middle. So we make all the ground control point around the area, not like in one side, because we need to achieve the accuracy for each side, not like for one side. Here also, this is the pipeline. We put all the ground control point around this pipeline. So we put each area, like if we have 3 area here, we put 3 benchmark around each area, less than 3-4 kilometer far from the area. 3 benchmark with a static surveying, like 12 hours per day to have this benchmark, and we achieve less than 8 centimeter accuracy. Also, you can see it later in Bix4D. We use Bix4D software to process this data. I will like to introduce, to invite Sam again to speak about workflow about Mavic 3 again. Thank you, Sam.
Thank you, Ashraf, for walking us through how you have done the drone operation in a challenging environment. So now we are going to see how the Mavic 3 Enterprise work in the real time. So we are going to see the workflow of how a team or how any survey survey companies want to establish this drone operation in their operation sector. So the first thing, we are using the Mavic 3 Enterprise drone in the field. So let's see how the Mavic 3 Enterprise workflow happens. The first thing first, we have to set up our base station, the DRTK. Any serving work, this is a fundamental rule. You guys might know that better. And we are setting up with the tripod because it should be stable. There is no margin of error when doing a survey work. So we are setting up the DRTK with the tripod, and it comes with a battery inside. And we are using DRTK as a course here in this region. You can also use as a 4G based server. So the next thing is unpacking and connecting the Mavic 3 enterprises. So the RTK module is a must, as I informed. That will give you a centimeter level of accurate result. So you are connecting the RTK module on top of that, which is a straightforward process to ensure the accuracy of the Mavic 3 enterprise. So this is a smart controller. So the next step would be establishing a relation between the controller and the drone. And also you have to cross-check the battery status, how much is the battery, so always it should be full time. And next is checking the DRTK base station protocols. So the positioning should be fixed, which is definitely a fixed solution. Without the fixed solution, your data will not be accurate. So once you have the fixed solution, just connect and cross-check all the parameters what you have, and you can ready to go. So DJI Pilot 2 offers different route mapping, which you can import it or you can create your own. Once you create your mapping mission, the next step would be connecting your drone to the controller itself. So you can select a drone and you can assign a parameter, the flight height, how much the altitude you want to fly, how much the speed drone wants to go, maybe 15 meters per second, how much overlap you want to achieve, maybe 80% overlap. Everything can be set up based on your requirement. Once you have everything meticulously planned, the next thing would be planning your region of interest. Let's say you have an area of 10 kilometers, but you want to only map 1 kilometer square. So you can select your region of interest as shown in the video. So once you have completed that, the Pilot 2 offers a pre-check, which is an essential add-on. So once you are okay with the flight check, the drone is ready to fly. It's simple as that. It's a straightforward process. So many people are afraid the drone operation may be difficult for them, but as you can see, it is a straightforward, simple process once you have everything planned. And currently we are using automatic capturing from the Mavic 3 Enterprises, in which every 0.7 second the drone captures an image, and that will be stored on an SD card, either from the drone or from the controller. So you can use any standard SD card to store the data. So it's a straightforward process from setting up the drone and connecting the drone to the controller, and setting up your DRTK base station, and using the specified point of your work. So once you have everything, the data will be taken by an SD card, and you can use either DJI Terra software or any third party like Pix4D or Aegis software to process the data, and you are ready to go. So this is a simple process when comparing to your other surveying work. And you can avoid using many as surveying instrument as possible, because with the one drone you are covering 2 kilometers square in a single flight, because of the ability it gives of 45 minutes, and the mechanical shutter and the CMOS sensor. So everything combined, your data is very confident to justify to our client. So Mavic 3 Enterprise, as I told, small yet powerful. But the next thing would be the flagship Matrix 350 drone, which I mentioned. So we are using Matrix 350 with both P1 sensor and the L1 sensor. As you can see, the L1 sensor as an inform, it's called the LiDAR sensor with the CMOS sensor. So the LiDAR one is used for taking all the point cloud references to use for your 3D modeling, or even in the public safety, they are using the LiDAR sensor to detect any object underneath, because any payloads, normal camera payload cannot penetrate in a vegetation, deep vegetation. I know there is not much vegetation in this region, but probably we consider Turkey. So there is a lot of vegetation, Turkey and India. So you want to penetrate deep underneath. So in that case, the LiDAR sensor is more beneficial to use, because with the P1, you cannot expect that accurate result in a vegetation. So with the P12, you are getting a normal full frame sensor, as I told, 45 megapixel full frame sensor, and you have an ability to change this. Yeah, please. So the full frame sensor, the P1 is similar to your normal camera sensor, which offers a 45 megapixel sensor, and you have an ability to change the lens depends on your use of work. So the P1 sensor comes with 35 as standard. You have option from 24 mm, 35 mm, and 50 mm, depends on your use of access. So it's pretty straightforward sensor, so you can just grab and check. So now the workflow starts with the M300, L1 and P1. Let's see how it goes on the P1. We are using the same base station setup as DRTK. That's added benefit. If you're using the DJI DRTK, you don't have to again change, because that's the ecosystem benefit. You are using the same DRTK base station for Mavic 3, M300, any DJI related drone. So once the base station is set up, the next thing is to set up the drone. And to connect the payload, it is a straightforward process again. It is just a simple connection, simple payloads connection. So again, and with the M350, the new added advantage is the arm lock indicator, which is very essential to ensure your drone is perfectly like fixed on all the sides. And with the new TB65 battery, from TB60 battery, you are expecting a higher battery cycle, which is 400 cycles. So now that's about the drone. So payloads, both the payloads have an ability to auto-calibrate. You have an option to auto-calibrate before your flight. You don't have to. It's an automatic function, or you can also do it manually. So now you can see the new RC, so which will give a 10-inch display to you to view your data more precisely and more visibly. So again, we are connecting the DRTK base station, and you can see the positioning is fixed. Fixed solution, definitely the surveying people here know fixed solution. How much important is the fixed solution is when you are using a normal GPS to use. So once you have the base station setup and DRTK station connected, the next thing would be again setting up all the parameters of your planned mission. So maybe you can plan about 100 meters, 80 meters. In this case, we have used 80 meters, and the planning and the normal 15 meter per second. So both the cameras are like planned according to your use of interest. So once you have all the parameters set, again, mapping a mission is what the next step would be. So once you have completely mapped your mission, plan your mission, the next thing would be checking flight pre-check. So when everything is perfectly aligned, the flight is ready to go. So here in this case, the P1 captures visible or RGB images, whereas the L1 also captures RGB with the point cloud. So in the next slide, I'm going to show you how it will be showing both RGB and the point cloud. So in this, you can see once you have everything set up and drone is ready to fly, in here you can see the RGB or normal JPEG images, but here you can see how the live cloud point of your workflow is showing. Later, we again show how the live view will be an added benefit for your end. So this is how we are using the DJI ecosystem or the DJI drones to help any service or any mapping companies from surveying or 3D modeling or mapping using a different DJI Enterprise drones. The Mavic 3 Enterprise is small and powerful again, and that can be used for your small scale application. It's still powerful to use for large scale, but you might be needing more drones to have it because it covers 2 kilometers square in a single flight. But if you're mapping hundreds of kilometers square of area, that's when the Matrix 350 with the P1 comes in picture, because it got the 45 megapixel sensor and you can cover a large area in a single flight with a battery of 55 minutes from the Matrix 350. With the P1, you can expect around 45 to 50 minutes of the flight time. So this is how we are showing the workflow of the DJI Enterprise drone. Simple and straightforward. If you have everything like planned beforehand, and you can import or you can use your own plan mission on real time. You don't have to like go back to your office and check how the cloud point looks. So again, we are taking the data and you can process it using the DJI Terra software or the Pix4D software in your office. So that's about the workflow of the drone. Now Ashraf will explain on the data software processing workflow. Thank you.
Thank you, Sam. Thank you, Sam. So we will speak about drone data capture, how we did to generate the ortho map and digital terrain surface. After we flew there in Fujairah, we have all the image geotagged with like when we connect with DRTK, all image has a coordinate. So later, how we do this processing in software in Pix4D. We process the image together, we align two image together to have, we call tie point. All the image together, we to generate tie point together one area. After that, we generate the GPS data, we align together with the drone image geotagged to have dense cloud. Here we have the raw image scanning. Later we have the tie point. After we have the tie point, we put the GPS data together to have to align with good accuracy. After that, we should have a dense cloud. From the dense cloud, we generate the ortho map and the digital terrain surface. Our aim for this project to deliver ortho mosaic or ortho map with a TIFF file. Also digital terrain surface with DSM and DTM. Also, we generate a 3D point cloud we call dense cloud with a LAS format, with also vector data to when we digitize all the area. We can see here the ortho map, ortho mosaic, like with less than 3 centimeter GSD. We can determine everything, even we can see the rock, because this project, we need, after like, you remember last year, there's heavy rains happened in Fujairah, so many rock fell down and covered the pipeline. So even we can recognize, when you can zoom in, you can recognize all the rock on the pipeline, you can recognize the trees, everything, because this is good resolution. This is also the sample of DSM, digital terrain surface. We can see here the blue color, like almost 215 meter above the ground, above the main sea level. So the green color, almost 230. This is like, you understand the terrain surface of this area. Also here, this is the vector data. We digitize all the area, like from the ortho map in GIS software. This is a contour line. Also, this is an unpaved road. We can put like in one layer. Also, we have the bushes and some trees. Also, this is the wadi area. Also, we have here the main road, some light pole also. Here we can say this is a point cloud, 3D color point cloud. Even you can see like almost a 3D. You can also generate from here 3D modeling after the point cloud. You can see everything with also the height. Okay, this is like a statistic of this project. Like our flight there, like 1.3 square kilometer. It took like from us more than 20 flight. drone, like we spent 2 days to cover all this area because it was separate like a location. If we have in one location, I think we can finish less than 2 hours. The ground survey days, it took 5 days to establish our benchmark and to measure all the ground control point. Like we have more than 35,000 image for all the area to process and 56 GB data. Also, our GST, it was 2.2, less than 3 centimeters. So the resolution, I think it was amazing. In this drone, we can see everything in ortho. When you can zoom in the ortho until 3 centimeter. So I will invite again Sam. He will go through with some advantage in Mavic 3 and M350. Thank you, Sam.
Oh, thank you, Ashraf. So, from the beginning, from the beginning of the workshop, we have seen how the traditional survey is and what benefit the DJI drones are added. So we have known, so the drone survey will be an added advantage if you're using as a as a drone photogrammetry or mapping related operation. So we in this we are seeing the key advancement or the key features which the DJI offers. So the first thing would be the smart oblique. The smart obliques features is from the P1 or now again available on the Mavic 3 Enterprises. So let's see the pain point. So on the current method, we are using the drone as a 2D grid where you are following a terrain in this area and in this area. So let's say you want to map 1 kilometer square in this area. So in 1 kilometer square, you are flying the drones 2 times on different angle, different what vectors. So you are capturing more image and you are spending more time. Okay. So but with the smart oblique features, the P1 can capture pictures from 5 different angles, back, front, and left and right, and from top. So with that, you don't have to go 2 times. With a single flight, you can cover all the 5 edges. So with the P1, flying over in one grid, it can cover all the 2 edges. So yes, you have to select the angle based on your requirement. Let's say you select a 45-degree oblique angle. So the P1 will be taking the pictures on all the 45 degree. So that will be ensuring a maximum efficiency when using the P1 sensor. Also with the Mavic 3, the latest update with the Mavic 3, it can capture 3 different angles, the smart oblique. The P1 can capture 5, but the Mavic 3 Enterprise can capture 3 different, which ensures the overall accuracy. And in this method, you might be taking 1,000 pictures, but with the smart oblique, you are reducing the picture size in which you are expecting a 20 to 50% processing time to. Yes, 3D mapping. So smart oblique is for 3D mapping. Once you have the P1 sensor, so after you are like taking the pictures, so the post-processing time takes more if your pictures are more. So once you have all the data capturing work, so you are expecting a more accurate result in less time. So that's the benefit of smart oblique, in which this is only offered by DJI Enterprise drones. So the next key advancement will be a terrain follow. As informed by Ashraf, they in their last project, so they have faced difficult terrain situation. It could be a mountain or hilly. So in that case, you are worried about your result. You might be thinking your result may be inaccurate because you are not because you are afraid of flying on a large hilly area, and because of that, your result may be affected. Also, there is a chance of drone crashing on an hilly. So with the terrain follow features with the both Mavic 3 Enterprise and the Mavic 350, the Mavic 3 Enterprises offers the new real-time advancement in which in real time, the drone will follow terrain and everything will be from the obstacle sensor. So let's say you are flying the Mavic 3 on a terrain of this situation. So using the obstacle sensor, the Mavic 3 Enterprises will automatically detect which height it should fly and which speed it should fly. So it ensures the safety of operation without causing any damages to your accuracy, because it will be always keep constant same high, same high. If this is the terrain, the drone will fly on the same high, but the accuracy data will be automatically synced. So that's the benefit of terrain following. So depending on your crucial work or your like crucial project, so this will be a benefit to use the terrain follow features on the drone itself. Again, this will be a single point. So when using the DJI drone on a pilot app, there is a toggle button. You just have to click the toggle button for a terrain map. Yeah, just switch it on, switch it off, depends on your terrain, and everything will be automatic. So there is 3 options for terrain following. One, I already explained, the real-time terrain following on the Mavic 3. The second one will be importing the DSM from internet, which is a digital surface model from internet, in which it will be taking the DSM of that area, and the drone automatically automatically adjusting using that. Its benefit for the Matrix 350 and the P1, because that doesn't offers real-time real-time advancement. Only Mavic 3 offers the real-time terrain follow system. And the third option would be using your own DSM if you have. Let's say you are using a L1 sensor to get the DSM of any area. So you can import your own DSM and use it as an option to create terrain follow features on the P1 or M350 itself. So this will be very beneficial when you are away from your normal work. So in a mountain or hilly area, you're flying and you don't have to worry about your data accuracy and your drone again, because that's an expensive asset for you. So with the added features, so DJI ensures the results should be more accurate and safely when you are justifying your client. So that's 2 features, and the last features, or the last key advance, with the point cloud live, which we have seen in our video. I'm going to explain it more. So with the DJI Pilot 2 app, with the L1, you can get both visual and the LiDAR. So this is a LiDAR-based real-time. So you can see how much accurate both the results are. The LiDAR take more time because of the 3 return principle of the LiDAR-based sensor. So that can, currently we are at altitude of 176. So, and the speed is 7.3 mph. So the L1 taking the data of both visual and the cloud point, and you can see on the live point, you don't have to go back to your office and take the data and pre-process it, because everything you can see here live. So with that, you have the ability to get 240 points per second. So let's speak about the typical LiDAR scanners, in which they offers 400 to 500 points per second. Yes, but with the drone-based service, drone-based payloads, you are expecting it to take more data per region compared to your traditional laser scanners, and everything will be live. I mean, you can view your point cloud data live compared to the traditional survey, where you have to go back and process and view the data. So you can also have an option to switch between the camera mode of the LiDAR and maybe the normal visual camera, and you have a ability to capture and save both the RGB data and the cloud point data. So once you have taken all the data, so you can just go back to your office and pre-process it using the DJI Terra software for more advanced and accurate result. So that's about the point cloud. So now Mr. Mohammed from Aerosmart will explain us how the DJI Enterprise drone benefit their clients when doing a survey in a tricky situation in Azerbaijan. So handing over to Mr. Mohammed.
Hello. Hi, good morning. This is Mohammed from Aerosmart. Thanks drone center, especially Scott, Ziad, and also the Sam and Ashraf for a detailed explanation about how DJI Enterprise can help in surveying and mapping. Is it okay now? Yeah. Okay. Okay. All right. So we Aerosmart basically DJI drone enterprise dealer. So we actually like work very closely with the clients. So one of the project I just wanted to talk about here is it's a client from Azerbaijan called Olymps UAV. So they got a project and the location was in Azerbaijan, and it's in survey area of 30 square kilometer. And the project is for aerial geodesy, and as you are aware about, this is basically the understanding of the geometry of the earth, so which cover most of the basically like vegetation area, maybe forest, water body, terrain, mountain. So it's included every aspect of an earth. So basically they wanted to do surveying and mapping and also some inspection reports. So, but the client had lots of challenges. So initially they were wanted to do with an Finder for multispectral, Finder for RTK. So we said that it's not going to happen. And usually any client, any what you call it, surveying company, they will first look into the initial cost of the equipment. You know, they will try to use the lowest cost equipment, but in end of the project, they might not get the real result. So we wanted to avoid all these aspects. So firstly, when we got any project from our the customers, either it's a reseller, consultant, or an end user, we will understand what exactly they want and in which country and what kind of scenario. So we will recommend the right product based on their project, because we need to make sure that they are getting the real and accurate data and to carry on the works and to be the best player in their country to get more projects. So it's a win-win situation for us, DJI, and for the client. So there are many challenges. The client, when they're explaining that the project will be carried out during the rainy weather condition. So because if it's a rainy weather, so you will have restricted operation, like you cannot fly during the weather. And there are, after the rain, you will have the fogs, maybe the wind before that. So there will be lots of, so eventually you will have actually the flying time will be very less. So your team might need to go there with all the equipment and wait over there for a good weather. So if you have the right equipment, and maybe you can even fly during the rain, you can fly even right after the rain. It doesn't matter there is a fog or not, because you need to adjust somehow with your result. Of course, there was dense fog. It also increased the hazards. And actually, they wanted to complete all this 38 square kilometer within, I would say, like 10 days. So it's like they need to fly on the night time as well. So we have to provide them the right equipment. And the one thing I would say that this is possible only with DJI, not with any other brand. LiDAR, P1, and a good platform, and the DITK2 station, and also the DJI Terra. So it's basically a complete solution that you can offer. I would challenge, not with any other product, with any other company that you go for, you cannot get all this thing in a one platform. So this is where we were very confident about and we try to convince the client that definitely you're spending your dollar on a right product, and you can achieve the result for sure. So we actually proposed DJI M300. Definitely it was like 6 months back, so there was an M350. So M300 with L1 and P1. So the M300, as you know, that it's really an ideal platform for any complex kind of work. If you wanted to do a 3D mapping, the terrain surveying, or vegetation index, and whatever you call it in terms of surveying and mapping, and M300, it's really a good platform, and it is very easy to manage and good maneuverability. So it's that the pilot can easily operate with high confidence. And there is a L1 camera that it is IP44 protection, ensures it will work very good during the weather. So that is one of the best USP with the IP4, the ZenMuse L1. And it can also use during the dense fog, and it's so that it's the lidar allows you to use during the night without the light. So that is the best thing. So you can cover, you can do any project with the night and day. So you're not missing any time basically. So you can complete a larger project in a very short period of time. And of course, because some of the clients, they might be going to in a remote area, so they go with all the equipment and the team, and they wanted to be on board to that place, and they cannot sometimes come back in a remote area. So better to go with all the equipment to complete the project in a short span of time. And the P1, of course, it's like it's a versatile solution. You can measure in difficult to reach areas and providing detailed result for mapping and modeling. For example, with a fixed wing, you might not fly near the building to take a 2D modeling or a 3D modeling. So it's always, exactly. So, and you cannot sometimes control so the best thing is that with the M350 or M31, with the more sensors, the drone is protected, and it is a very accurate sensor, and it will act based on the obstacle, very quick way. And this is, they were executing the mission, and it's a very large area. As you can see, there is mountain, so there is the forest, and you have plain land, terrain, and everything. So the result was basically like a LiDAR point cloud and a 3D smart oblique for some buildings over there, and 2D mosaic or drawing. So basically the result, and these are the words from the client itself, and the team was successfully completed a 30 square kilometer project within 2 weeks in a given period of time, and including the data collection, processing, and everything, and delivering the result to the client using an M300, L1, and P1, sorry. Yes, sometimes it was mounted together. You can use a dual mounting bracket. Yeah. And you can switch on which camera you want. And sometimes it is just like a P1. So it's based on the scenarios. So if you're using the two payload at a time, it will definitely decrease the flying time. Yeah, so it's a case to case, they switch on. And very impressive detail, the best-in-class camera of the ZenMuse P1. It's a 48 megapixel camera. As Sam was explaining, in a detail about how P1 can work in a better way. So delivers remarkable and highly detailed result, and very high accuracy photos, they could create the 3D to the maps. And about the M300 or M350, compared to any other mapping drones, M300 stand out as the best solution because it can integrate LiDAR, P1 when it comes to the surveying and mapping, and if it go for other solution, there are lots of payloads basically. But talking about specifically mapping and surveying, it can, the same platform can use different payload. So that is the best option. You don't need to buy another drone, to use a different payload. So we always say the customer, it's an investment on the platform. So if you own an M300 or M350, you can just keep it and keep buying your payload, and whenever DJI release or based on your requirement. So it's a real investment, and I would recommend that if you're a GIS company or a surveying operator, so this will be the right choice. So yeah, I think that's all, and we just move to the Q&A.
Thank you very much, everyone, for speaking so far. There's a few takeaways before I get questions from the audience. A couple of things on this drone, not mentioned so far. If you're undertaking a large area, you can save that area on your software, and you can revisit it because we appreciate 100 square kilometers cannot be done in one day. Also, if the aircraft is continuously flying, when it lands, you can smart swap the batteries, and then the aircraft will continue the trajectory where it left off. You don't have to restart every single time. But there are some takeaways on this platform. It's ease of use, larger area covered than traditional methods, and accuracy of data. Traversing difficult situations are easier done through drone technology than traditional methods. So when you're working with clients, you're adding value because you're speeding up the process and you're improving your data sets. What we've shown today is the ecosystem of DJI. It's intuitive. You might have a smaller budget. You might want to start and work your way up, depending on those situations. The Mavic 3 Enterprise has the same interface, the same controls, the same basic capabilities, which are improved with the Matrice 350 series. The LiDAR solution can be used as a recon. You go into an area where you don't have a digital surface model already, you don't know that terrain. Google Maps may be limited in data. It's 2.5D maps, actually. And you may want to traverse that terrain before you actually accomplish that 3D image. The LiDAR can be used to create that 3D image for then the drone to go in and navigate better. We were talking about automated flight and navigating it. The LiDAR can be used in those situations. And that is a common occurrence we're seeing when people are wanting better quantitative data. They're using both the LiDAR and the photogrammetry to create that more accurate result. So I just wanted to mention that. Thank you very much for the information shared today. I hope you found it insightful. There's only so much you can cover in a session of this size, so we've barely scratched the surface. We've showed how feds undertake their work. There's a lot of information that we can share, and I appreciate sometimes it goes in one ear and out the other ear. It's the same with me. We will share this information after this event, so if anyone really wants to absorb that work process, we will share that with you, because we want our success to be shared with you as well. We want to share the secrets of undertaking work efficiently, because it does seem quite complicated, but it's muscle memory. Once you undertake it once, and then the second time, and then the third time, it becomes easier. So I hope you appreciate that. We condense a lot. So this part, I'd like to open up the floor. Any questions that people may want to ask regarding the workflow process, the hardware. We are going to be showing you the software. So after the Q&A session, please feel free to come over, explore some of our data sets and how the software works. Our team will show you how the software works if it assists you. Any questions? At the back? I'll tell you what, we'll just hand over a microphone to you.
I didn't hear, okay, I know that most of the things and most of the programs that you guys use, like DJI Terra, are autonomous. Can you use them manually to either survey or map?
Can we use the...
Can you manually map and survey without using any autonomous?
Yes.
Oh, okay.
You can do. So you can physically fly that aircraft. Traditionally, the more unorganized the images you take will improve your data set. When drones first came about, the initial flight plans were too organized. So a static shot here, point B, point C, point D at the same angle. The more variance you have in your data, the better the 3D image. So when you're looking at what Sam was showing, with the Mavic 3 Enterprise, you have 3 angles at which you capture. The more disorganized the information, the more angles you capture will improve that data set. The P1 does 5 different angles, oblique angles. And if you're manually controlling that aircraft, you might want to add even more layers of images that will improve the accuracy of your data set. Of course, when you're surveying, you want to overlap those images because you may have variances of foliage and trees. And the more angles you adapt, the more information you can absorb. So some people, and sometimes the Feds team, will actually manually control the aircraft just to add a little bit extra data if they're not happy maybe with that accuracy. So that is something you consider. You may appreciate also if you are revisiting the same location, you can save those profiles on your software that you can share with your team. So you'll have an online account and you can save that data on the cloud or you can save it locally. That information can be shared with your team and then they can revisit and they already have that profile set up. But you can actually increase the overlap, you can increase the complexity of the flights if you wish to. With the P1, because you have that full frame sensor and because you have 45 megapixels in that full frame, it means you don't have to take as many images. And that's what the benefit is. It's the pain points of using a smaller sensor. It's the pain points of only having ground-based perspective, which takes more time to get that data. You want the bigger sensor, you want the faster processing to shorten the amount of time, to reduce the cost, and to save the client money. So at the end of the day, it's talking about what's the best sensor, what's the fastest way in which you can undertake it. And drone technology typically is allowing surveyors to do this much more efficiently and much faster. So doing it manually, you're taking one step back again. And my advice is you don't need to do that, because the P1 sensor allows you to get all those extra layers. So you can do it, but I don't recommend it. That's a very long way around it. Any other questions?
Is that the only feature that you can use with the enterprise? What I'm saying is basically do matching for the end. For technical. So for example, if you do mapping, you use the DJI enterprise solution. Is it different from, let's say, Pixel 4D that offers you, for example, you can take a tower, a 3D model of a tower, or is there more features than just mapping?
Yeah, so you're talking about end users. So you're talking 2D mapping, 3D mapping, or traversing a tower, a flare stack, an object of interest. You can still control that through the flight software, the DJI Pilot app. You can also use third-party software solutions. The remote control is operating Android, and there are some companies out there that allow you to download their application and operate through that application. There is flexibility. You can do so. We would recommend using the DJI interface because of the ecosystem and its intuitive nature. But you can, if you wish, I know you mentioned that earlier on today, use Drone Deploy. It's more basic and it may not capture the same amount of angles as to what the DJI software offer, particularly when using an enterprise product, because essentially those 5 angles are done through that DJI software. I can't guarantee that a ported software or third-party software program offers that same flexibility. My advice is consult with them first and throw them the problem. Typically companies will say, oh, what's your problem? And we'll recommend the solution for that scenario. The Feds team do a lot of flare stack inspections using the DJI Matrice series and the P1 already, and the data is accurate. So it's down to the requirements from the client, accuracy of data. We managed to get 2 centimeters of accuracy, but that was using the PBK that the team is so expertise in. You can use the RTK, Sam was mentioning, the module, the ground station. That gives you more accuracy than a consumer drone because they're using satellites and you only get maybe maximum 20 centimeters of accuracy per pixel, flying at around 100 meters. Increase it with the RTK, increase it even more so if the client wants more accuracy by creating a ground control point, post-process it, exactly. That might be a more effective way of improving your data set. Because you take that data, you run it through the software, you correct it by introducing those ground control points and improve the data set. It does require more manual input, but you will improve that data. But that's what Feds are so good at doing and what other clients are.
The markers would just say, let's say you put them 50 meters apart, you measure the distance, and then you basically say to the system, they are 50 meters
That's
apart.
exactly how it works. And DRTK2 will triangulate its position with the antenna sets in the country. You can actually use an RTK without that, but you're increasing the variance. That knows where it is on planet Earth, And when you're increasing the areas where we know that's exactly that distance from here, you're improving the data on the drone. I know where that is, so I know I'm this distance, but also the further away I am, I'm increasing the variance again. Let's introduce more of these waypoints. Okay, let's bring that accuracy in again. That's how it works. It's as simple as that.
And another question is about the terrain, uneven terrain. When would you really need to use that feature? Let's say the terrain is about 5 to 10 meters, a bit like, not like huge hills. Would it be enough to just fly at the same level, let's say 50 meters, 100 meters, and just don't use the feature? Or would you say 5, 10 meters is already like something that you would want consistent?
5, 10 meters, there's no problem. The sensors will give you the accurate data, especially LiDAR. Remember, it's using a LiDAR-based point cloud reference. Mavic, yeah, more than enough. That's fine. When you're looking at maybe the mountains in Figueira, that's when you need to traverse those more hilly mountains because you have a bigger variance of data. Again, it's down to what the client wants. What accuracy do they want? 5 centimeters, typically good enough for them. So if you have a variance of 5, 10 meters, the software will automatically calibrate and give you that data set. And remember, the terrain following mode of the drone is automated. It's using a sensor. I think the drone was passed around. On the underside of the aircraft, it's using a sensor to detect constantly the height between the drone and the aircraft. Okay, so it's using a combination of visual and infrared sensors. So typically 50 meters, I think, if you want more accuracy. 80 meters maximum. So typically when we're flying these types of drones, consider the altitude to improve your accuracy also. If you can manage a lower accuracy, especially with this drone, we maybe 50 meters maximum. The smaller sensor requires flight lower to the ground to increase your accuracy again, but also to allow these sensors to work better. So the Matrice 300 series affords higher altitude because of a bigger sensor and allows greater coverage. When you're scaling down, you also need to think smaller, lower, more images. And that's the compromise with a smaller drone. You're flying lower. You're taking more images.
You wouldn't use this tool in, let's say, populated areas with the huge buildings.
So for populated areas, then you need to understand the legislation as well. Oh no, that's a good question because
Buildings above 50 meters or something,
that's right.
that's more like a helicopter journal, I would say.
Not necessarily. It depends on the location. It depends on the zone in which you can fly, the permissions that you require. But we may as well touch on this subject because everyone always wants to know about legislation. The way in which feds undertake their work, first of all, you need to undertake an understanding if you can fly in that area. And in UAE in particular, we know there are different emirates and everyone has their own stipulated regulations. Typically in Dubai, for example, you'll need to apply to the Dubai Civil Aviation to undertake that flight in that quarter. You'll also need to consult whether or not you can fly there. You have green, amber, and red zones. Green, safe to fly. Amber requires permission. Red requires an NOC from all of the landowners in that area and also an application to DJI through their software. So in order to undertake that area, for example, if it's Dubai Airport, very difficult. However, you have an NOC from the landowner. You can then take that certificate from that client. You can then contact DJI, inform them you have permission to fly there. They will process that application automatically through your remote control. They will update the software for that period of time, allowing you to fly there. Then you need Ministry of Defence on site each day. So we understand that there are barriers to entry, but this is not rocket science. The reason why feds and other survey companies are operating in this region is because of the process in which they follow. There are charges, yes. The clients are aware of those charges. Once you undertake it, you perform the flight, you charge the client appropriately, the data is still far more accurate, far more cost effective, and less time consuming than traditional methods. Plus you have multiple angles, whereas on the ground level, if you want to undertake 3D surveying of a built-up area, it's so time consuming for that data. But feds have conducted flights downtown because they've followed the process and the legalities. I can't tell you the clients, of course under NDA, but we have been able to fly and operate there. Look at chopper shoot as well. We saw the Burj Khalifa shot, Emirates. It is possible, yeah, it's absolutely possible, as long as you follow the guidances and the rules. Now, we are here to help assist everyone in this room to understand better those rules and regulations. Many people are concerned, many people, it turns them off, it turns them away. If you want to consult with us and feds after this, we're more than happy to work with you, to guide you, to support you. We are going to be releasing a video series, more content on the regulations, because I think this is #1 concern for many people, but it can be done. Again, it's not rocket science. So I hope that answers your question regarding that. Cool. Any other questions? Oh, everyone wants I've done it at the seats at the back. Well, the front will do afterwards.
Assalamu alaikum.
Assalamu alaikum.
My name is Samia. I am from Fujairah Natural Resources. Now you talk about a drone, about mountain. I want to tell you that we are expert to fly the drone on the mountain. Already we cooperate for all the mining sector. And most of the mining sector, we take it by DJI drone. And we make it as a 3D also. We calculate the volume for the mountain before do blasting. And we will calculate the volume after do blasting. Other thing, I want to ask, when we will take video by drone, we have DJI Matrix 300, and we have P1 and L1 also. For the building and structure, it is not clear when we will take it by 3D. Can you give us any solution for that, especially for the factory, cement factory and other factory building? It will not be clear when we will take it 3D.
Okay, first of all, welcome. Thank you for being here, and well done on using those products. The challenge is the amount of data and the altitude in which you're flying. I assume that there is one altitude in which the drone is being operated. And again, following a previous question, the more angles of approach on that building, the variances in altitude will improve your data set when you're looking at a building and improving that 3D model. So it may require more manual flight, more manual control around that building, as when you automate, you're limiting those angles. And when you're at one altitude, you only have one perspective, essentially. Imagine a building, I'm flying at a certain altitude, and then a second altitude, and then a lower altitude. You're adding more data at more different angles, improving your data. My recommendation is, when you're looking at those factories, increase the differentiating layers, increase the amount of data, different angles.
Sorry, we can also fly like a facade mapping around the building. If you have the manual, yeah, exactly. You can set like 45, or like you can set 0 also. Automatically, not yet now in DJI, but later. Yeah.
It should be manual capturing.
More manual. And the reason why it can't be automated is the limitation in the sensors. The benefit is, when you are operating manually, you're letting those sensors avoid obstacles. And per se, if you're flying near that factory, you may appreciate there are obstacles. The collision avoidance sensors on the Matrice 350 series are far more advanced than the Mavic series, albeit they are in each quarter of the aircraft, there are blind points. If you're operating in those environments, the Matrice 300 is better because it has 360 collision avoidance. That's a very good question. And it's interesting that that is a problem that you have. But The Feds team have undertaken similar projects and introduced more manual flying for that particular type of data set. Again, look at different altitudes when you're flying around that building and increase the amount of images and overlap more.
But instead of using different altitudes, we have P1 and this oblique camera also we are using. It has 5 lenses, if you know.
But
So
at one
even
altitude,
after
it
using
might be
that one
limiting.
also, we are not getting the expected results.
Yes, because again, you're using potentially one altitude or you're using multiple altitudes around that building.
Important, same altitude.
Same altitude. Again, my advice is next time you undertake that same flight, 100 meters, 80 meters, 50 meters, then
But
see if
again,
there's a
if you
variance.
use that, it will be a huge data, which will be not possible to process, right?
Again, there is
There will be a huge
limiting
data, no,
factor.
data file.
I mean, you can compare the data between 180, 100, when you fly 100 meters, you can compare and you can check at 80 meters how much data you can get and process it. So you can compare the data and increase or overlapping. What's the overlapping reducing now?
80.
Yeah, so you might increase to 85.
Yeah.
Increase the overlap. Secondly, there is another piece of hardware that we supply. It's from phase 1. And the P1 may be the limiting factor for the type of data you need. We do a 100 megapixel.
P1 we are just using it for the topography inside the terrain,
That's right.
especially inside the mountains.
But again, if you have a problem, we may have a solution. We have a more capable camera, even more so than the P1,
Sure,
100
we will discuss.
megapixel, and it's a bigger sensor even still than the full frame. So again, we could trial that with you. We could see if that improves your data.
Sure.
But we've encountered this problem quite often. And again, simplify it. More angles. It will increase your data set, but you want more data on that building. Remember, sometimes more is better. That limiting of one altitude is your problem at the moment.
Also, Scott, you can use multiple altitude. Each altitude use different angle, like 145 angle. Go down, change the angle.
No. There is angles are fixed. If we are talking about the P1 oblique camera, it has fixed angles. If you are using this P1 camera, you can fix the angle, right?
Also, Mavic 3, you can change the
Yes.
angle.
Manually, you can fix
We
the
are using
angle.
different angles.
You can
obviously.
do that, yeah. Remember, more chaos in your pictures, the better. So if you're just using 45 at every angle, it's not chaotic enough. Maybe more sporadic images, random images would improve your data set. I hope that answers your question.
Thank you.
Any problems, we're here to help consult and maybe improve that data. I think there were more questions at the back as well.
Good morning, Scott and everyone.
Always good to see a familiar face. Like the new hairstyle.
A quick question. Are we able to connect 2 RTK to one drone?
You can reverse it. You can connect more than one drone to one RTK. 2 RTK, I'll give that to Ashraf.
Wasn't simple question.
No, it's not a simple.
You can connect, yeah, two drone in one DRTK. Okay. Okay. You need to disconnect and connect again from the. Yeah. Okay. Okay. First, you cannot connect 2 benchmark to one drone. What you will do is your benchmark make it as a network. So later, when you process as this benchmark as a network, whatever you connect from the beginning, first benchmark to drone, later disconnect and connect to second benchmark, third benchmark. You know, corridor maybe you will have 10 benchmark. Like you need to connect each section alone.
Bandwidth is a limitation. My advice would be look at 2 drones. RTK, drone.
We are not getting exactly data, this correction. So we have to use this GCPs again, even after using this base station.
Of course, if you need to go like with 10 centimeter accuracy, 5 centimeter accuracy, you need GCP. Like DRTK with the model, it will not give you like this 5 centimeter accuracy. You will go with like 30 or 40 centimeter accuracy without GCP.
But you know, in the terrains of Fujairah, most of the site like that, we cannot reach there. So how we can minimize the error? Is there anything special in Mavic 3 or 350?
Overlapping and altitude, two things. Keep it simple. The higher, the more levels of inaccuracy. The less of an overlap, the more the higher level of inaccuracy. Increase your overlap, increase the angles, and decrease your altitude potentially. My advice in Fujairah, there will be a lot of power lines,
Yes.
and you're worried about collision avoidance. There is a module you can attach to the drone, a radar module. It's called the CSM radar. That will attach to the top of the drone, and it will detect any power lines, and it will prevent a collision. I would advise looking at that. It's plug and play. Sits on top of the drone, and then you can fly lower and not worry about collision with power lines as well. So lower, more angles again. We'll increase your data set. If you want more accuracy, increase the amount of images, increase the angles. That's it. Simple as that.
So we have to, you know, make more flights, and we have to increase the overlap. That's
Again,
all.
yeah. If you want more accuracy, then do that. Absolutely.
Okay, thank you.
What about this real-time option? We can use it in the smart controller?
Real time.
Real-time option, we can use it in the smart controller for RTK 300, Matters 300?
Exactly.
Sure.
Yeah, exactly. You can
Yes.
use it.
Is this
Yeah,
available there?
Of course, it's available.
I'll check with you. Thank you.
Thanks.
Perfect. Good questions. Whoops. Anyone else? Any other questions they want to ask? I think at the back.
Right? Someone else have a question?
Here.
Was it the same question? Was it good? Please. Mobeen?
DRTK, yeah. So when we start a base station, ground station, so it is always connecting to the drone. Okay, this is the first point. And the next thing is that we need to put a station with a georeference coordinate, known coordinate station. It's like lat long, yeah?
Yes.
So we can input the data, and the next thing is that, is it possible to give the local coordinate system, like northing, easting, to start the base station?
Local coordinate system you cannot put inside the drone because the drone is flying like an Earth WGS, not like local.
WGS 84.
So you can put DRTK in known point, like you have the coordinate, you can put like a manual inside the RC, or you can put like unknown point, it will calculate the coordinate by itself. But the local, because you know local has so many
all
issues.
all the time we need to convert the local coordinate
Exactly.
system to lat long, right?
Exactly.
And the next thing is that when we are going with the RTK system, so it will collect continuously, no need to establish any GCPs.
It will connect, like if you are near to the RTK, like the pilot should be near to RTK, like 200 meter, 500 meter, 500 meter, like you will have like consistent like connection between RC and the RTK.
500 meter.
Yeah.
Okay. That's perfect. Yeah.
You know, feel free to share what you're doing, and if you feel you're not getting the level of data, we can look at that data set and maybe make some maybe we could make some recommendations. If you're okay to share that data set, we could look at it compared to what feds usually do with those scenarios, because they have undertaken survey work in Fujairah before, and they might say maybe you could look at doing this, because obviously you're looking at improving your data. But we're here to help. That's the whole reason you're here today, is to try and improve that data. Your problem is our problem. If you're not getting what you want, then we need to work with you to get what you want. Okay.
Is it possible to record the video in L1? Sorry, P1?
Yes.
We can plan a mission and continuously recording the video with P1?
No. The intended purpose is a photogrammetry still camera. So for video use, less so. It depends on your end use. If you're wanting to take video footage, just use the Mavic. You'd be best set doing that. Or maybe using the H20 payload. H20. Yeah. But remember, the P1 is intended purpose still images for photogrammetry use. Then you have the H20 series, which is more of an inspection payload designed for video, reconnaissance, surveillance, video inspection. So again, the P1 wouldn't be, it's not intended to do that. Yeah. So there are multiple payloads you can use, just plug and play, essentially. Ahmed, all good?
Basically, some of our customers, they are using L1. They used to mount with the M300, and now with the M350. Some of the customers are complaining that is there any additional setup they need to do with the M350, because when using L1, the photos are overexposed. So is there any special settings they need to do, or it's just like they just wanted to do the auto?
Yeah, so the automated settings may be a limitation in some areas. It is a 4/3 inch sensor, and the automated software program may not be as effective as controlling the ISO manually. So easy to do in the settings, top 3 dots you'll see in the controller. You can then edit your ISO settings to manually change those, maybe reduce your exposure. That is true across all DJI platforms. If you have a sudden shadow, then sudden brightness, you might find that it takes time for that exposure to change. Whereas manually, it may be best to have it more controlled and dial it in. That's my advice in those scenarios. Quite rare, but it does happen, and it's happened to us. So again, advanced planning. As a surveyor, you plan, right? And you need to plan based on the conditions, the environment. Don't go in there with a mindset, it's going to do everything for me. You're the experts, so you're adding value to your client. If you weren't experts, anyone could do this. And in this moment in time, your intelligence also adds value, because sometimes it needs the human interaction to improve it. Depends. Most of the time, automated is more than enough. Exactly, it is, yeah. And you'll appreciate that as a photographer as well. In the consumer sector more than enterprise, manual ISO control, everything.
So would you say it's better to keep it manual, or it's better to keep it automatic if you see that the
It's scenario based. How long is a piece of string? Depends on the situation. You have flexibility to have automatic or manual control. That is the benefit of using this technology. You're in full control. You command the aircraft depending on the environment. If the weather conditions are variable, control it manually if you're more comfortable to do so. That is the flexibility. Even bind maybe your remote control to change those settings to give you more flexibility.
But let's say you keep it manually and you don't change the exposure. So let's say your exposure is nice when it's sunny, and then the cloud come in, and you're just afraid to change the exposure settings.
Then you will fail.
And then you keep it. So that is a problem. Yeah, you have to adjust.
No, you would be the problem, because you're not adapting to that environment.
Okay.
So that's when automatic may be best served. Or you capture the footage with those conditions, stop, change the settings when those conditions change, and then continue. You would be the problem in that scenario. So again, introducing human error.
The problem is in some regions is that there's like clouds coming in and out, like literally every minute.
That's right.
And this is a very, very complex situation.
So then that comes down to planning. If you're a surveyor and you have too many variables in the weather, consider flying when the conditions are more stable.
I wish you can have that option, but sometimes you just have to fly that day, and the clouds coming in and out all the time.
Sometimes I wish the cameras had windscreen wipers as well when it's foggy and then it's raining. But again, there will be situations. Nothing's perfect. Pole body's perfect. I say that quite often.
Would you just put
variables?
It in automatic?
Exactly. But again, that's where your expertise comes in as a surveyor and as an expert conducting a drone flight. You assess the situation. There will be times where you can't fly. There will be times where the conditions here are too hazardous. There will be variables that affect the performance of operating. It's happened to feds many times. There will be times where Ministry of Defence can't be on site. You have to cancel. You need to use intelligence when you're operating as a surveyor. It won't always be perfect. I've been in this industry 11 years. If you go looking for problems, you will find them. It's how you overcome them. There will be hurdles along the way, but it's best to understand the basics of how to operate the aircraft first, This is why we're having this session. Then the legalities, conduct it appropriately. Then you will have variables of the actual weather itself, so plan ahead. Part of our operating courses, our training program, Hadi is at the back of the room here. We are improving our training program. We're looking at the start of next year to have a standardized training course which also includes weathering systems, training people up understanding planning ahead is not just about the location, but it's about the weather. And these have huge implications on the performance and the reliability of you as an operator. If you know it's going to be cloudy, if you know it's going to be windy, then you need to plan ahead. Choose a better day. Provide that to the client. These are the basics when you're doing your permissions course back in the day, when you're doing the A2 course in Europe and when you're in America. A lot of it is understanding weather systems. So when you're a drone pilot, it's not just about flying a drone. You want to cover all corners. Hope it helps. Online questions, okay. Okay, so we got one here. The best flight height in the city should be 50 meters with a maximum height of how many meters should be set for the Mavic 3 Enterprise, or how should the remote control be set for a better and optimal flight? Again, with the Mavic 3, with a smaller sensor, depends on the environment. If you have a very built-up area, you want to consider how tall those buildings are. You want to operate safely. So my suggestion would be assess that area first before you undertake the altitude of the aircraft. Next one, how many LiDAR points will capture in 1 square meter? That's a question for you, Ashraf.
Yeah, it will be like more than 300,000 point in 1 meter.
Okay, so
basically the LiDAR, the L1 captures 240 points per second. So you can imagine how many points per area it can capture if it's 1 square kilometer. So every second the L1 with a 1 return will capture 240 points per second. If it is 3 returns, which means the L1 data is synced every 3 rounds. So that will capture 480 points per second. So in a 1 square kilometer, you can get a millions of points per second.
Millions of points.
No, the L1, basically the L1, in a typical scenario of 80 meters, it will capture 240 meter per second, 220 points per second.
Oh yeah,
yes,
of course.
Yeah, definitely, definitely. I'm saying in best condition, suitable condition.
Yeah, of course, if it's windier. But remember, the aircraft will traverse in those conditions. That's why you have all of the layers of redundancy on your aircraft. The flight time will be affected if it's windier. And again, that's down to your planning. If you know it's going to be windy, do you want to fly in that day? If you are going to fly in that day, compensate for it. There will be more stress and strain on the motors. They have to work harder. And when you're walking in the wind, it's terrible for me. I'm 6'4", I'm like a big sail. I have to work harder in the wind. It's the same with a drone. So consider these as part of your operation. Cool. Another question? Yep.
PPK.
PPK.
So if you are having a PPK model, so you're running a drone, so still you need a DRTK in that?
PPK, Ashraf, you want
No PPK model, there is RTK model.
RTK, and you have a PPK?
No, just
also,
RTK.
right?
This is
Yeah.
RTK.
It's RTK.
RTK is
Okay.
already when you attach with the drone will connect to the DRTK.
In your slide, you were showing that it's a PPK is also possible. That's what
PPK.
yeah.
This
That's
is
using ground control points.
that one when you measure the point.
Uh-huh.
Like if you don't have a good signal for how many satellite, like you have less than 20 satellite, what you will do, you will measure all the ground control point. Like with rapid static, you will post-processing later, like in the office. We call this process PPK to measure the ground control point. But the flight will be like with RTK.
So its antenna is recording the RENX format, right?
Here it will no, all the image will be geotagged with the position.
Position, yeah.
Each image will have long latitude, longitude, latitude coordinate system. Also, it will have ellipsoid height when the drone is flying in the air.
Okay.
When you post-process, you're taking that data captured real time, and you're using extra layers such as ground to then improve that accuracy. The data you have may not be as accurate. You reconfigure it and then recompile that data, and that's how you post-process a kinematic data set as well.
So still we required DRTK in that?
We always recommend, if you're using surveying, never use it without the DRTK2. You can use it with other ground station solutions. If you're a quantity surveyor and you use Leica, it will work with the DJI infrastructure. However, you would need manual entries, longitude, latitude, in order to calibrate the drone. So you can use, but this is the most intuitive. It's plug and play. If you want it easier, it will give you the same accuracy, in our opinion.
Easy to work.
Very easy, very easy, and it works with ecosystem.
Again, same question. It's PPK is available or not? Is PPK is there?
No, this is RTK,
RTK
only. When we are talking of PPK, it's talking about our post-processing of that RTK data.
Exactly.
So if you want, in terms of PPK as a module, no. There are other platforms out there that offer the PPK module, but because the RTK is so accurate, it's not really a major undertaking. And how we improve our accuracy if we're not happy with the RTK is to post-process that RTK data. That's the difference.
Thank you.
Hope that answers your question.
Thank you.
Mohammed? Oh, we'll be back in. That's a good question, actually. It won't stop mapping, but I think it informs you if there's
the
a
connection
drop in connection.
will be between the connection should be between the pilot, the RC, and the RTK. You should stand like far from the RTK, like 400, 500 meters. The drone, the connection between the RC and the drone will be like 2 kilometers, 3 kilometers. Sometimes like we open it.
If the RTK disconnects, it will inform you. It informs you. No, if it's mapping, then it's using GPS. If you drop with that, then you yeah, if you're not using RTK, you will have to.
You can fly, but later you need to do post-processing the image. There is like multiple third party of software. PPK is the image, but I am not sure it's working like RTK. Because now in DJI, no like software, you need to geotag the image. Because each image should be has like a coordinate.
When you're flying the aircraft without the DRTK2, essentially this will improve the accuracy and stability of the flight of the aircraft. And it will also, a second mention, when you're operating the ground station with an RTK module and you're flying near a power line, it will improve or prevent electromagnetic interference. Because you're flying near a power source, it may knock out your GPS. However, because you have a ground station, it will continue to communicate with the drone. So that's also another added benefit to a DRTK2 system. Okay, any other questions? Ahmed, you had a question?
Yeah. We got some feedback from the customer. When they're using the DRTK2 station, it improved the efficiency of the landing the drone. When they're doing the automation, when it's mounted with maybe the phase 1 or then H20T, maybe three payloads together. So they're saying that they feel very confident about the landing the drone without any obstacle, and it's very accurate from the takeoff position. Is that true, or it is just like?
Typically, when you're operating a DJI drone, many people don't realize, but when the aircraft takes off, it takes a static image of the ground. And when it comes back into land, it overlays that image and it uses it as a reference to land the aircraft. So that might be a myth. So the aircraft itself is designed to overlay that image and land exactly where it took off. Also, another useless bit of information. When you hear the motor start up, when it makes that do-do-do, that's the vibration of the motors. There's no speaker. It's quite interesting. Little things like that. So this is one of the benefits of using this type of technology. These are used for accuracy of landing. The infrared are used for low light conditions. They're less accurate than the visual sensors for collision avoidance, they're used in the daytime. But when you have a lack of visual data, it will fall back on the infrared. When using in low light conditions, understand that you will reduce the capability of your collision avoidance. So do consider these things. One more question? Okay, Mavic 3 Enterprise can PPK process using PPK processing software using static base station Rhinox data. Can you use the post-processing software using PPK? Yes, you can take your RTK data and you can process using any third-party PPK processing data. You take that information and collaborate it maybe with ground control points to improve that. So essentially you are post-processing that RTK data. Yes, that is possible. Hope that answers your question online. Thank you very much. Any other questions? Everyone looks a bit tired now. Sick of hearing me speak. There will be coffee that will wake you up and refreshments upstairs.
So we'll be starting the interaction section on the Pix4D software now.
So please, if you want to come and have a play around with Pix4D, I'm sure some of you will. You may or may already not be using the software. Feel free to do so. One last request. These pieces of yellow paper, I didn't give one to you, kind sir. If you can fill these in and hand them in to us, preferably now, that would be great. We want to give you certificates as well of attendance. I believe we have these just at the front here with everyone's name on. Take them away if you wish. It can be useful for future work with clients. It's an attendance certificate. It's an official DJI certificate, attending a surveying mapping seminar. So please, we'll give you one if you fill in the yellow forms. That's how we'll barter with you. Perfect. And then once you've done so, feel free to go upstairs, coffee, refreshments, ask us questions. Oh, perfect. So we got the Pix4D software here up on screen. In fact, Ashraf can take us through a little dry run here, DSM modeling and DTM modeling. Remember, when you're capturing the data, for those who aren't using it, the information you take, you pull it automatically into the software. Depending on the capability of your computer, you can compile that information into a digital twin, 2D orthomosaic, point cloud reference, depending on the hardware you're using. DJI Terra will also do the same to a certain extent. Pix4D, they have more variations of software allowing different types of data sets. So this is one that we took earlier. I think it's Fujera, wasn't it? And DTM. So you can use the same data set and emphasize different parts of that data set as well. This is P1, is it? Oh, Mavic. This is Mavic. Yeah, Mavic. Yeah. One thing to note as well, you see here, now another thing to bear in mind, when you're looking at overhead transmission lines, you can't see the power lines. If you were to use an L1, that will detect and that will show up these lines. So sometimes the scenario depends on the product. In Fujera, I'd imagine the L1 will show those power lines, whereas a P1 will look better on ground, but the intricate details will be lacking because it's not using LiDAR.
So here you were flying above the power lines on the same altitude? Yeah?
Above.
Above.
Yeah, so it was 50 meters?
Like 20 meters above the power line.
And that was enough to cover all
Exactly.
Yeah, that was enough.
Had to use the feature for the... Did you have to use the feature for the terrain, following the terrain?
Here it's the area, it's not like hilly or mountain, like you can see, this is the wadi area.
This was the question before that I asked. Is like, this is what, about 10 meters?
Here, like, you can see in the...
Is there any way you can show how high we were flying?
Here, it was 120 from the takeoff. Here we can see like at 215, here 230, like 15 meters the wadi area.
And this is fine, you don't have to use that feature, and you have good data.
You take it from the road, so 120, like above the area.
Remember, it's an option you can select, terrain follow, or you can deselect if you're not happy. And there's too many variations, maybe, because of the power lines. When you're operating a Mavic,
this is the exact scenario that I was asking. You know,
the P1 will, the Matrice 350, you can attach the CSM radar, so that will detect these power lines in that scenario, and you could go full stick forward, and it will not fly into that power line. It's there as a safety net, but many people, many operators fail because they use a collision avoidance as a tool they always use. It should be the last case scenario. It's there to protect you, but don't use it as a method of approaching a scenario. You don't want to go full stick towards the power line. There may be a scenario that prevents it from operating. That's the biggest issue. Emergency services are typically worse for that, in my experience. As operators here, I'd imagine you'll use more intelligence when operating. But don't use the collision avoidance as the standard when flying near an object. It should just be a safety net. Still operate with caution.
Basically, when you're planning a flight, you just have to make sure that you're flying above.
Exactly. And an L1 here, if you don't already have a DSM or a DTM, a digital terrain model, if you don't already have that data to input, this is where the L1 may come in quite useful. Do a recce, fly the L1, capture the point cloud reference, input that data to your flight controller on your remote control, and you already have the most accurate data in terms of altitude. So when you use a terrain follow mode, you know that you're using real-time live data. That's why maybe, I don't know if you're using the L1 for those scenarios for the mountains, create the DTM first and then fly with the P1. That's where many clients are using both L1 and P1. They're using the L1 to detect the terrain, input that data, then fly it with the P1 using the terrain follow mode.
A bit more advanced, I would say. Let's say if you only have Mavic 3.
It depends on the scenario. If it's 10, you don't need that. If it's a Mavic 3, that will do, as you saw there, a very good data set. Okay, so feel free. You don't have to stay planted to your seats. If you want to have a play around, please feel free to do so. If you want to have a coffee first, also please feel free to do so. I hope you've all filled in your yellow sheets there. And then if you come over here and hand it to Sam, Sam will give you your little certificate there as well.